Welcome back. In this video we are going to discuss about eigenvalues and eigenvectors. So let us first we see the square matrix is there, then and then only we can find eigenvalues and eigenvector of the matrix A. So it is necessary to have the matrix A should be the square matrix. So let us see first the definition of the eigenvalues and eigenvector. So let A be the square matrix of order A, and if there exists a non-zero column vector, that is column matrix X and scalar lambda, such that we can write Ax is equal lambda x, then the lambda is known as the eigenvalues of matrix A, and non-zero column vector whatever we have, that is X, and that should be the non-zero. This is non-zero vector, and then only we can say that it is known as the eigenvector corresponding. So whenever we consider the eigenvalues and eigenvectors, so first we will determine the eigenvalues, and after that we will find the corresponding to that eigenvalues we can find its eigenvectors. So let us first understand eigenvalues are also known as the characteristic roots, or you can say latent roots, or you can say the spectral values or property roots. Now whenever we consider X is equal lambda x, so we can write X is equal lambda x. I is nothing but unit matrix of order whatever it is. If A is a 3 by 3 matrix, so we will consider identity matrix of order 3 by 3. And whenever you simplify this one, and whenever we take X common, so what I will have A minus lambda I. A minus lambda I, and that is known as what exactly eigen matrix, or you can say that the characteristic matrix. But whenever you find it's a polynomial, because this is known as determinant of A minus lambda is known as what exactly eigen polynomial, or you can say the characteristic polynomial if polynomial of order n in lambda. That means we will have whatever this determinant A minus lambda I, it will be in terms of the lambda, and that will be the what exactly characteristic polynomial in lambda. In other words, you can say eigen polynomials in lambda. So the equation, whenever we consider this equation, when equation are there, then we can find its root. So roots of this equation is known as the eigenvalues, and whenever we find its eigenvalues, and based on that we can determine this eigenvector. So let us understand first properties of the eigenvalues. The sum of eigenvalue of the matrix A is sum of its principal diagonal. What does it mean? The sum of eigenvalues, that means lambda 1 plus lambda 2 plus lambda n is nothing but sum of its principal diagonal elements. That means whatever we have the matrix, if I say 1 2 3 2 3 4 1 0 minus 1, this is the A matrix of order 3 by 3. But sum of the eigenvalue, whatever we have the eigenvalues, so if I say this is lambda 1 lambda 2 plus lambda 3, and that will be equal to sum of its principal diagonal, that means 1 plus 3 plus minus 1, and this is known as the principal diagonal elements. So 1 plus 3 minus 1, so we can say this is 3. So whenever you find the eigenvalues and when you add it, so it will be exactly sum, or you can say trace of the matrix A. So trace of a matrix A is same as sum of all values on diagonal. Sum of all values on diagonal. So whatever we have the values on this diagonal, that will be the our trace of the matrix A. So product of the eigenvalues of matrix A is the determinant of the matrix A. Suppose you have that the lambda 1 into lambda 2 is equal lambda 3, that is our eigenvalues, but when you take its products, and that will be the what exactly determinant of the matrix A. The eigenvalue of the triangular matrix are, suppose we have that is the 1 0 2 0 3 5 0 0 1. So we can say this is what exactly upper triangular matrix. This is known as upper triangular matrix. and whenever we see upper or lower triangular matrix, so only the diagonal entries will be what exactly our determined eigenvalues will be there, and based on that we can find determinant of A is nothing but lambda 1 equal to lambda 2 equal lambda 3. So we can say this is 1 and this is going to be 3, and again this is 1, so we can say this is determinant is nothing but 3. The eigenvalue of two matrix A and A transpose are same if eigenvalue of A inverse are the reciprocal of the eigenvalues of A. Suppose you have given that eigenvalues of matrix A that are 1, 2 and 3. So what will be the eigenvalues of A inverse? That is the lambda inverse. So 1, 1 by 2 and 1 by 3. Suppose A is there and suppose I want to determine 2A, so it will be what exactly 2 lambda. So we can say eigenvalue of that matrix 2A will be 2, 4 and 6 and so on. If lambda is the eigenvalue of the matrix A, then the lambda raised to k is the eigenvalue of A raised to k, and that we will keep in mind whenever we have A is there, and suppose I want to determine that the A raised to power cube as the eigenvalue, that is lambda cube, 1 raised to cube that is 1, 2 raised to cube that is 8, 3 raised to cube that is 27. If lambda is the eigenvalue of the matrix A, then the lambda plus or minus k is an eigenvalue of the matrix A plus or minus ki. If I say this is A plus 2i, so what will be the eigenvalue? So what I have to understand, eigenvalue of this matrix is nothing but 1, 2, 3, that means lambda is there, and then I have to add, that is the 2, so I have to add here plus 2 only, and so in that case what you are going to get, 1 plus 2 that is 3, 2 plus 2 that is 4, 3 plus 2 that is 5, and that will be the eigenvalue of this one. And this is already I have explained you. So matrix A and A transpose need not have the same eigenvector. That thing we will keep in mind, because both have the same eigenvalue, but doesn't mean that they both have the same eigenvector. So let us understand characteristic equation of the matrix A. So whenever we have the given matrix of order that is 2, so lambda square minus h1 lambda plus h2 is equal 0, and that will be the characteristic equation. Otherwise you may understand A minus lambda equals 0. Now just simplify it and you will get the equation, and whenever you find its root, and that will be the characteristic roots, or you can say eigenvalues of the matrix A. But in other words, you can write lambda square minus h1 lambda plus h2 is equal 0. But what is h1 and h2? So here you have given that the matrix, suppose that A, B, C and D, and suppose I want to write here h1. h1 is what? Sum of the principal diagonal elements. So A and D is nothing but our principal entries of that matrix. So otherwise you may say trace of the given matrix. So we can say A plus D, and that will be the h1. h2 is what? A determinant of this matrix. So how we can determine the determinant of 2 by 2? So we can say whenever we have the order 2 by 2, so in that case determinant will be AD minus BC, and that will be the what exactly S2. Whenever we replace all these values, so we will have the characteristic equation in degree 2. Now you can find two eigenvalues. Suppose we have the order 3, so in that case what? So in that case lambda cube minus h1 lambda square plus h2 lambda minus h3 is equal 0. So here h1 is nothing but principal diagonal element, that is trace of the matrix A. In other words, you can mention trace of A. S2 is what? S2 is nothing but the principal diagonal elements, whatever it is, and in that case we will consider minor of that. That means suppose you have given that A, B, C, D, E, F, G, H, I. So whenever I consider this one, so minor of each diagonal entries. So when I observe minor of this one, so I have to eliminate this one, and what I'm just going to get, that is E, F, H, I plus. But when I eliminate this one, so I have to hide this one. So what I'm just going to get, this will be the cancel out. So I'm just going to get A, C, G, I, and when I consider only minor of this one, so I will eliminate this one. So what I will have only this one, so we can say A, B, D, E, and therefore this is known as what? Exactly S2, and S3 is what? That is the determinant, and that is what? That is you can determine. And but whenever you replace S1, S2 and S3, so you will get the characteristic equation when we have the matrix A of the order 3. So mind well, S1 is nothing but sum of principal diagonal elements of the matrix A, that is known as trace of the matrix A. S2 is what? That is only sum of minor of each element on the diagonal entries. And third one, S3 is nothing but determinant of the matrix A. So first plus minus is there, that means alternate terms are there. So let us understand first question. A is equal, this is given. Find the eigenvalues of the matrix. So from this what I have to assume that matrix A is there. So this is what? Determinant A minus lambda is equal 0. Whenever you assume that, so you will get this type of, because A is there, I just want to assume that lambda I, but lambda I is nothing but here 1 0 0 0 1 0 0 0 1. So what you are going to get, that is only lambda 0 0 0 lambda 0 0 0 lambda. Now you need to consider A minus lambda, that means you need to subtract these two matrices. 3 minus this one, that is lambda, minus 1, that minus 0, that is minus 1, 1 minus 0, that is 1, minus 1 G minus 0, that is minus 1, 5 minus lambda, that is 5 minus lambda is there, minus 1 minus 0, that is minus 1, and same for the last row. So you will get this one. But whenever you find its determinant, also you can get its characteristic polynomial. There is no need to consider S1, S2 and S3, but for our simplicity you might be use here S1, S2 and S3, where S1 is nothing but trace of the matrix A, S2 is nothing but sum of minor of each elements on the principal diagonal, and S3 is nothing but determinant of the matrix A. So let us first assume that this characteristic equation. Now first we are going to consider trace of the matrix. So 3 plus 5 plus 3, and that is going to be what? Exactly 8 plus 3, that is 11. Sum of minor of the principal diagonal elements. If I focus on this one, so I have to add this one, so what I'm just going to get only this one, and that is you can see 5 minus 1 minus 1 3. Suppose I want a minor of this one, second 5, so I have to eliminate this one, so 3 1 1 3, and that is we have. But when I focus minor of this one, so I have to add this one, so I will get 3 minus 1 minus 1 5. But when you simplify, so you will get that is a 36, and S3 is nothing but determinant of the matrix A. So 3 into this product 15 minus and minus, that is plus, and minus, that is minus 1, minus minus plus 1, and minus 3 plus 1, and 1 is there, so plus 1 minus 5. But when you simplify, so you will get 36. And therefore the characteristic equation lambda cube minus 11 lambda square plus 36 lambda minus 36 equal to 0. But whenever you solve this, whenever you factorize this one, so you will get lambda minus 2, lambda minus 3 into lambda minus 6 is equal 0. But question arises that how we can find its factorization. So whenever you see this kind of, so first observe that the divisor of the minus 36 is what? That you can say plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and so on. So first start with as lambda is equal plus 1. Just put your lambda is equal plus 1. If you get the answer that is 0, then definitely we can say that the lambda minus 1 is the one factor. Then use lambda is equal minus 1. Just put it, if it is non-zero, so it is not there. What about lambda is equal to? If you get lambda is equal to 2 here, and if you get the answer that is 0, so we can say the lambda minus 2 is the one factor. So what I'm just going to say that if lambda minus 2 is a one factor, so I have to determine here that is the quadratic form. So for that I'm just going to concentrate that coefficient of each lambda cube, lambda square, lambda and constant, that is 1, minus 11, 36 and minus 36. But we have verified that the lambda is equal to is the root, so I'm just going to put here lambda is equal, that is 2. So plus 0 is there, 1 plus 0, that is 1. Multiply 2 into 1, that is 2. And when you simplify, so you will get a minus 9. But when you take a product 2 into minus 9, that is minus 18, so you will get plus 18. 18 to jar, that is 36, and you will get that is the 0. Whenever you get that is 0, that means that whatever we have assumed that the one factor, that is okay. So we get 1 lambda square minus 9 lambda plus 18. But when you simplify, so you will get degree of lambda, that will be the lambda cube, and that is we have. Again you can factorize this one, and so what you are going to get lambda minus 2 and 18 is there, coefficient of lambda square, that is 1. So 1 into 18 is nothing but 18, but we want here, we want to split that 18 into two parts so that its addition is the minus 9 and its product should be the 18. So what I'm just going to consider 6 into 3. And that product is nothing but 18, but its addition should be what, that is minus 9. That means I need to consider minus 3 into minus 6 so that its product is plus 8 and its addition is going to be the minus 9. Therefore it is going to be the suitable. So we can say lambda minus 3 into lambda minus 6 is equal 0. So from this we can conclude that lambda is equal to 3 and 6. So matrix of A, eigenvalue of A is that is 2, 3, 6, A transpose, it will be same. Eigenvalue of A inverse, just take its reciprocal. Eigenvalue of A square, just take lambda square. Lambda's 5A, that means just multiply by 5, so you will get this one. I want A plus 2I, so whatever we have, just add last 2 and you will get this one. And if we have the matrix A is there, and suppose I want to find the eigenvalue of the matrix A, so in that case how we can find? So for that you should keep in mind that this is what exactly upper or lower. So upper triangular matrix are there, and therefore we can say that whatever we have the entries on the diagonal entry 1, 2 and 3, and that will be the what exactly on the eigenvalues. So your given matrix is upper triangular, so eigenvalues will be the elements of the principal diagonal elements, that is 1, 2, 3, and that will be the eigenvalues. Here I'm just going to find the eigenvalues and eigenvector for this matrix. So try to understand that how we are going to find eigenvector. That means we want to find your x, so that Ax is equal lambda x. So first we need to consider its characteristic polynomial so that we can determine its eigenvalues. So I'm not going to discuss all these S1, S2 and S3. Now you are able to determine S1, S2 and S3, and for that and after that you can find its eigenvalues, and therefore we have its eigenvalues is that is 0, 3 and 15. But now it is clear that eigenvalues are there, and from this what you can determine for your understanding, I'm just going to discuss that trace of this one matrix is nothing but sum of the eigenvalues. So that you can see that is 0 plus 3 plus 15, and that is going to be 18, and that is what exactly sum of all the entries of the diagonal entry, principal diagonal entry. And then determinant of A, that will be what exactly lambda 1 into lambda 2 into lambda 3, and that is one of the eigenvalues are 0, so therefore definitely its determinant will be the 0. So this is eigenvalues, and now I'm just going to find the eigenvectors corresponding to these three eigenvalues. So for lambda is equal 0, so I'm just going to consider a minus lambda x is equal 0. If I put lambda is equal 0, and when I consider, so what I need to consider, this is going to be 0. So only this matrix A, x, column vector x, y, z, 0, 0. And now I'm just going to use grammar rule. But whenever I consider the grammar rule, so I have to opt two rows which are independent. And for that, if I assume that first 2 by 2 determinant, so it is going to be the non-zero. That thing you can verify. Also you can assume that this one, that means again it is going to be the non-zero. Suppose you get this is the 0, again if you get this is the 0, again 8 minus 6, 2 minus 4, again its determinant is going to be 0. That means we are not going to consider first two rows. So instead of that, what you have to do, you have to do the remaining next two. That means you have to consider this one, either this one. So for this particular question, I'm just going to consider first two. This is from the first equal row and this is the second row. So whenever you consider its first two equation, and when you solve using the grammar rule, so what you are going to get? X divided by, just hide this one, so minus 3 1 minus 7 4, and that is we have minus y, just hide it, 4 1 6 4, that is we have z, hide this column, so what you will get? 4 minus 3 6 minus 7. But whenever you find and simplify, so you will get this one, and whenever all the ratios are equal, so in that case we will assume that any arbitrary number that is set even and which is belong to R. So x is equal what? That is the minus 1 into t1. Y is equal what? X is equal minus 1 into t1, y is equal minus 2 t1, and z is equal minus 2 t1. But when we take t1 common, so I will get minus 1 minus 2 minus 3, and that is going to be what? Exactly x1 is nothing but eigenvector corresponding to this eigenvector. Here this eigenvector may be differ from the someone, because when I choose t1 is equal plus minus 1, so all the values will be what? That is 1 2 and 2, and that will be the plus. So let us understand, when we assume that lambda is equal 3, I have to follow the same. So I am just going to consider a minus 3i, but when you simplify, a is there minus 3i, so you will get this one. So there are three systems from this matrix form, and whenever you consider first two, so you will get using the grammar rule, you will get this one, and whenever you take t2 common, so you will get this one, and this is the eigenvector corresponding lambda is equal to, and this is lambda is equal 15. So just apply lambda is equal 15, and a minus only diagonal entries, subtract it a minus 15, so you will get this one. Whenever you write the corresponding system, and when you choose the first two, otherwise first and last, whatever you like. So here you can choose any two. So if you suppose to choose first two, you can use, otherwise suppose you want to choose this one, also you can. To keep in mind that any equation should not be multiple of the others, and when you apply the grammar rule, so you will get this one, and this is the eigenvector corresponding to lambda is equal. So in this video we have discussed about the eigenvalues and how we can find its eigenvector. Thank you.